Okay, are you ready to for the full break? Already left. Okay. Yeah, some of them. Yeah, it's fine. You can record the video. You can watch the video. So again, no class on Friday. I will try to record the video tomorrow. If not, I will find some video for you to watch. If I don't have time to do that. And so then we'll see you next Friday. Yeah, next Wednesday is the exam, but you can take it anywhere. Like just do it on your own. Okay, don't try to coordinate with your classmates. And it should be easy. 3 questions. Uh, only 3 questions. 1 hour. 15 minutes actually, but I give you 1 hour. And if everyone is doing great, fine. I will try to make it easier for other assignment. If everyone is doing not so good, I will make the assignments easier in the final exam. But I will give some extra credits. Everyone is doing very bad, so you have to coordinate with each other to not doing well. Then I will give everyone some extra credits. Otherwise, you will get what you get. And yeah, so that's so the exam will be the same for everyone. And so for the final project and for the final project, I will expect a little bit more from graduate students than undergraduate students. So if you're seeing here, although this is the same class for both graduate and undergraduate, but when I'm grading the assignments, the final project we have higher criteria from graduate students. So you need to make sure that you do a little bit more, to be fair. Okay, otherwise, you are a little bit more advanced than undergraduate, so you have to do a little bit more. So for today, I want to continue with the analysis, and I think all we are going to cover today is one of the most important concepts in Google Sensing. And why Google Sensing is so powerful, you need to master the content today, okay? Although last time we already talked about zonal statistics, under the hood, it used the concept, some of the things we're going to cover here. And if you use Google Sensing, to me, the most powerful function, or what function have you used so far do you think is the most powerful? Have you used anything that you feel is powerful? Or have you feel the power of cloud computing yet? Yes? So what are the benefits? Yeah, instant access to data. And what else? Convenience, file format, speed. Right. So far what we talk about mostly data access, visualization, but we have not really covered like the real power is doing analysis. And this one thing you need to keep in mind is how do you optimize your algorithm to be able to process tens of millions of images just using one line of code. So what we are going to cover today is that we're going to cover my favorite function in Google Sensing is the map function. The map function is the most powerful one. We have not used it. I mean, we use some of those under the hood, but you need to master this one. If you master this one, you master cloud computing, doing parallel computing and batch processing. Okay, and it looks weird, like map function. What is that? It's not like creating a Gmap. Okay, the map function is like doing the looping, kind of like Python. If you have used Python, how do you do looping in Python? For loop, yeah, same idea, but it's different. So in Google Ads Engine, you should never use for loop unless you're trying to add the data layers. Other than that, if you're doing the computation, never use the for loop. For loop is for client-side computing. For Google Engine, if you use a for loop, think about here, you need to wait until the first one is finished and go to the second one. So it's like sequential. But Google Engine like parallel computer, you can think about all this computer here. I'm sending the command to each computer and run the computation and return the result back. So that function is called map. I'm going to show you here what does that really mean. There's also a reducer. Let me see, reduce. Yeah, probably I didn't. Let me see if I cover it here. Double check again. I think I introduced in the, yeah, I think it's under the create time lapse actually. I'm going to skip the analysis to introduce this one because the reducer somehow also use this one, but I want you to master this map function first because this one is, I think is the most powerful function that you, if you master it, you will become a master. Okay, so I'm going to go to here, skip to number 9. I will come back to the analysis next, but I think this one you have to understand that what does that really mean. So let me run this here quickly. You can think about the map function is Python for loop, but it's the server side looping, and this is why you can like process a million images just one line of code using the map function. So here, let's try take a look at this one first. e.list.sequence, okay, 1 to 10, so you get these 10 objects. So this is kind of similar to the traditional Python programming in the client side. Again, Google Engine server side programming, okay. If you're doing the client side, how do you create a list of numbers in Python? Not Google Engine, right? How do you traditionally range? Okay, so for example, I in range, right? Something like this. And so if you start from 1 to 10, okay, let's make it simple. Like how do you do that? So print out I 1 to 10. So this is basically a list, and or you can do it like in Python, in Google Engine, e.list.sequence. So the sequence also from 1 to 10 is inclusive. So the starting and the ending, so you have 1 all the way to 10. If you're using Python, you need to add 1 to the stopping criteria. Otherwise, you only get 9 numbers. So this is right now a list. So keep it in mind. Like I said, right now we have 10 numbers. So think about, it doesn't matter. You can have a million numbers. Think about what you want to do with each number. Right. So simple example, I want to calculate the square of these numbers. Right. So how do you do that? Right. In regular Python, you'll be like this. Here, I will just print out, for example, maybe how about this? I can get a variable here, maybe called square equal to list. Okay. And then I can say square dot what? Append, and then I multiply by I. Okay. Make sense? Oh, it's uppercase. I need to lowercase. Right. Okay. So then I can print out. Make sense? This is how I do it. I mean, it's fine. You can do it like this. I mean, you can also do it one line of code. You'll be like this. You'll be, what's that? I multiplied by I for I in range, and then 1 to 11 to be the same result. So this is more like called list comprehension. So if you have a very simple one, you can do it like this. So for something, in something, I'm going to apply the same operation to each of those, right? So in here, it doesn't have to do square. I can maybe do like to the power of 3, right? Do the same thing. No. Or double star, yeah, you're right. So I can use double star like this. 1, 2 to the power of 3, like 3, something like this. Just an example. I'm saying here. So right now I'm going to use this one as example. So this is how you do that in Python. It's doing a looping. So next, look at this one. How to actually do that in Google Engine. Again, never use the for loop. Okay, you're gonna it's very inefficient. You can, but it's not good because it's not optimized for parallel processing. So, and this is the function how you calculate um the create a function. Actually, I can, yeah. So create a function, give him a number, and then this is the name of the function. Return e dot number, and then to the power of 2. So again, right now we're not using I multiplied by I. Because this is a Google ascending number, you don't necessarily have to use like e dot number, but just to be safe, if the number is not an Earth engine number, you will convert it to the Earth engine number, and then by the power of 2. So it's going to give you a number, I give you square. But this one is the server side programming. And then once you have the function, so look at this one, what's the differences in here? So this list is the list we generated above, right? And then, so basically you are calling this function map, and then passing the name of the function, okay? Nothing else, just the name of the function. So the name, the function, your parameter should only accept one parameter. That parameter is your element. So think about here, this is a list dot map, and then have function. So when, for example, starting, let's say from 1, what it's going to do is to call this function, passing 1 here, and 1 to the power of 2, it's going to return 1. So the result going to be 1. And then the second one, 2, right? So 2 is going to call this function, passing 2, and give you 4 return. So if you look at this one, return result, right? 1, 4, 9, right? The same like the one in here. Make sense? So basically the map function can be applied to a list, to an image collection, to a feature collection. So basically an image collection and a feature collection is also a list. So always keep in mind, if you want to do something, if you want to do the same operation to everything in the list, you just create a list and then dot map. The what you want to put inside the map is a function or a lambda function. A lambda function is a anonymous function, but basically everything like this. So this is, like I said, one line of code is the power of in here. So we can design whatever you want to do with within the function. It just return the result. So for example, if you want to get the power of 3, right, like this, you can do the same thing, right? Or you can say so maybe how about this -1? I think it's called subtract, right? Subtract, for example, let's say 1. Okay. See? And it doesn't have to be one right now. This is only one step, but you can have multiple steps if you want to. So one thing you can do like this. If I'm asking you to create a R3 mosaic for the state of Tennessee for 30 years. So think about how I'm going to do that. Yeah, you made a list, and then you need to use the map function to clip to the imagery for all of them. So anytime when you are asked to do something for many years, for a time series, whatever, forget about it. If you can figure out how to do that for one, you can do that. It doesn't matter how many you have. It's all basically just adding one more line of code is to add a map function. So if you get an image, for example, in the US, you want to clip to Tennessee, then you just dot clip, right? But you can create an image collection of all the images for the entire US, and then you get like variable, for example, it's called images. Then you'll be images dot map. And then within there, this is the function. So it depends on how complicated is your function. If your function is only one line, then you can use this one here. So this lambda function, okay, lambda number colon. So basically means that, okay, you give me a number, I'm going to do this. I'm going to return the result back to you. So the result is going to, after you finish all this, is going to be another list. So this one is the same. The lambda function is the same as this one, except Lambda function is like just one operation, can be done in just one operation. But if you have multiple, you need to do like very complicated one, then you still want to define the function like this. Okay, so it's up to you what you want to do. So right now, if for example lambda like this, so just master these two, and I can show you. Let me cloud free composite. Yeah. So let me give you an example how you can how about this? Let me do the landscape imagery. Okay. Let me find a better example. I'll show you. Last time I think there's a, for example, I create the it's visualize data using the time slider. So I can show you what it is. So the time slider, okay. For example, here this is vegetation data. So let me come back to here, and let me add an example here. You will understand the real power. Okay. So right now, this is, think about here. Will be quick. So I'm adding the vegetation data, right? So this one, like I mentioned, it has 30 days, right? Yes. And so what I'm trying to do here, they say I'm interested in this area. So take a look at this one. So for example, I'm working on this area. I'm just going to draw a rectangle, right? So I have 30 images, but my area is this one. I only want the images clipped to this one for the entire image collection rather than all of them, right? So how I'm going to do that? So here I can maybe, let me get this one, map dot user RI RIS. Okay, so this is the feature collection in here, right now this is a feature collection. So what I need to do is, because I already have the image collection, right? So right now I'm trying to do the same operation to this one. So what I can do actually is just very simple. Copy here, okay, and then I'm going to create a new code block in here. Okay, so you be image collections, and I can maybe create another variable called images dot images equal to, okay. So think about what you want to do for that operation, like collections, and then what? Dot map, yeah. And because it's very simple, it's just going to clip to the images. So I don't need to define a function. I just use a lambda. Okay. So it's going to be lambda. Okay. And then the name, basically the temporary variable. The variable name doesn't matter. It can be anything. So I can say, for example, image. Okay. So that means I'm going to do the same operation to each image. So in here, you'll be image dot what? So how do you clip to the image? How do you clip to an Earth image? Yeah, you want to here, because I'm using feature collection. I'm going to just clip to collection, okay, and then you'll be map. So, oops, make sense? So think about here. I have the image collection. I want to do the same operation to each of them. So right now is a simple one. So I'm going to use the lambda image dot something something. So this name here doesn't matter. You can choose any name, okay, as long as it's the same. So basically, this is an element of the collection. So it's a single image. You can choose whatever you like. And then I'm going to clip to this one and then do this. So, oh, by the way, this is to be images, okay? It's done, pretty much. That's it. Oh, spanning? Oh, okay. As simple as that. It's all done, just one line. So right now I'm clipped to 20 images. So if you want to test it, figure out, I can copy the same line of code just to show you what it is, okay? So here I'm going to paste this one. So right now I don't need this anymore, okay, because the collection is already change it. So now this will be images. and then run it. It's already clipped to the images. Take a look. Right? Although, I mean, that one is non-geodesic, so it's non-rectangle, but it's not a major issue. But the point is that now I have an image collection that's clipped the same operation. And this is the real power, because it doesn't matter how many images you have. Right now, we're dealing with 30. It can be 300. It can be 3 million. It can be 30 million. It will do the same thing. It's super fast. So the map function is, like I said, is my favorite function. If you know how to use it, you can do a lot of things. This is why it's very powerful for parallel computing. Okay, so this is just using Lambda. Of course, I can clip to the function. I can also maybe because after you clip to the function, clip to image, clips collection, it becomes an image. So you can do all kind of things to an image. For example, you can, they say here, for all this NDVI, right? For example, okay, I'm interested in doing vegetation. I'm interested in extracting the vegetation, like using NDVI. Right? See how easy it is. I can just apply the same function here. So it will be this one, clip to the image, and then I can extract NDVI greater than, for example, 0.1. Make sense? So I clip the image. It's going to range value from -1 to 1. I'm greater than 0.1, so most likely it's going to be vegetation. Okay. So once I have that, of course, this right now, maybe I return because I don't want to. Maybe I can see, I can still use it, but the color might be different. But what I'm doing here right now is to be a binary image, yes and no. Oops. Oh, I need to. Do you run this one? Oh, I didn't run it. Run this one again. It should be different. So right now, basically, I'm doing the same operation. Oops. Parameter collection is required. To the let me this one first. Oh, and the we are, yeah, maybe just change this one. I don't. Oh, because you might not have the name. So anyway, I'm just going to just add the first image back to here. Just show you the map dot add layer. Okay, images dot first, and then square brackets, and maybe just the first one. See what it looks like. From the collection is written. The collection click this one. Yeah, it should work. Anyway, I'll look into that later. But supposedly, you can do a bunch of operations to the same image. So figure out what you want to do with one item, one element, and then you can just use the map function to do anything. So it can be a number, it can be a list, it can be anything. So let me go back to this time series. And this is where you can use the map function to create time series for any location you like. So here, this is the, no, this one. Yeah, this one. So this is where you can use the map function. So I'm going to come back here again. Time lapse. Go down here. So take a look at this. example. Let me go up the noise. Yeah. So create tile-free composite. So here I'm just going to select just one country, for example, Netherlands. Okay. And you can given an area, given a geometry or feature collection, image collection, you can create time series images for any pretty much any satellite sensor, as long as it has the time series. So what we are doing here, look at this one, list sequence 2013 to 2022. Okay. So what I'm doing here is that, okay, I want the time series images for this country for every year, right? So if you know how to create that for 1 year, you can do that for every year. So all we need is just to create a list of years, and years.map, and then you have a function. Given a year, you give an image, right? I give you another year, you give him another image. So that year, you need to design the function. So this is where this one is doing the work. So keep it in mind here, right? We define a function, yearly image. So you give me a year, I'm going to, based on the year, I'm going to construct the date, right? So the January the 1st, and then advance 1 year. You, for example, if you give me 2013, I'm going to get the start date would be 2013 January 1st. And then the end date would be advanced 1 year, you'll be 2014 January 1st. But the end date is not included, so it's actually 2013 December 31st. Okay, so the start date is January 1st, 2013. The end date will be December 31st, 2013. And then use those 2 days. I'm going to do the filtering, right? So this is length 8. I'm going to filter data for all the year, and then I'm going to filter the boundary to that feature collection. Once you have the image collection, so basically I'm getting all the images for the Netherlands for 2013, and then I'm going to call this algorithm algorithm the length set to simple composite, and then just passing the result, all the images in here, and lastly keep to the collection, and we have an image, and then we're going to return an image, right? So this is basically the whole function doing multiple operations. So give me a year, I give you the image for that year, and then I do the cloud-free mosaic, and then I clip to the area, and I give you the image back. So if you give me another year, I give you another image. You give me another year, give me another. So the essential thing here is to figure out what you want to do with this one. And once you have that function, then you'll be the same operation. It's always going to be the something dot map. So it's image collection dot map, or list. In this case, it's the list of years, right? So from 2013 to 2022. So there's this one, right? All done. And the lastly, this is where you use the looping. So if you don't use the time series, time slider, even to add all the data layers to the map, then here you have to use the for something, right? And then image, images. So basically this one being written is a list. So I can print out here, for example, images. So this one is a list. So list can, Google Engine has a .get function, and then based on the index. So basically you have 10 items. So the first one, the index is 0. So what I'm doing in here is like I'm doing the looping for 10 times. So the first time I'm going to get the index. So the first time the index is 0. So basically I'm getting the first image. But like I said, it's an element. Sometimes you have to explicitly convert that one to an image, because otherwise sometimes Google Engine is a compute object. It doesn't know what it is. So what it's doing here, okay, I have 10 elements. Give me the first element, index 0. And I know that one is an image. So I'm going to convert that one to an image. And with that image, now I can add the image to the map. So if you run this one. So this one is a little bit slow. If you have like more than 10 layers, you probably don't want to do this one because it's going to be pretty slow. Okay. Yes. No, FC, it needs to be some coming from somewhere, because I already run it here. So the FC is here. So it's already defined. You need to define, otherwise it's no. Oh, it's already added, right? See all the data layers, right? All the year. it might be still be loading, but you already have all the 10 years that I just added. Okay, so here you click it. It's a bit slow. That's why I don't recommend like you add all the data layers, right? So it doesn't matter how many years you have, how many locations you have. So now if I ask you, okay, create cloud-free mosaic for the state of Tennessee, starting from 2016, right? Every year, it'll be something like this. Uh, right now it's a little bit complicated, but Google Gmap has just one line of code. You can just create. You can look at other examples, but right now I'm showing under the hood. This is how you can create time series images. Do the same operation. You do the filtering, and so basically you need to design a function. The function only has one parameter, is the element. So given a year, I give you an image. Give you another year, I give you an images. You can expand that. You can do monthly. Give you a month, I give you an image for that month. Okay, so I can ask you create a mosaic for the state of Tennessee over Knoxville for every month for the past 20 years. How many? Right? We give you a year. Yeah, that one's a bit more complicated, but I can say 12 months for the last year. Okay, 2022, January, February, right? You give me 12 images. So what you need to do basically, you create a sequence, like either this sequence 1 to 12, and then from that you're gonna pass in here, for example, 2022, and then the year, right? The month first, and then you use end date of the month 1 month. So we're gonna start from January and then move to February and something like that. Keep in mind just to see how you apply this. You can do so many things. So basically allows you to do repeated operation to all the elements within a list, or all the images within image collection, or all the features in a feature collection. So take some time to digest this one. It's a bit confusing at the beginning, but basically what you need is to figure out whether you want to use the Lambda function or you want to design a function. If there's a Lambda function, it's always just one line. Oh yeah, use time slider when you have more than like five. Yes. Put them all on the back. Yeah, it's up to you. So this is certainly, I mean, you can compare the two data layers all at once. So I can, it's not, it's like good. 30, 40. Yeah, no, still no. If you have more than 10, don't do it. Okay, it's not good. Okay, but this at least can show, for example, can change the opacity. So time slider more like when you have a lot more. In that way, you don't have so many data layers. Okay. Yes. So the Lambda, so if I come back to here, in here. So Lambda, so basically within here, right? If you define a function, it's just passing the name of the function. If you don't have, you'll be just Lambda x, and then you do something to the x. So I can do it here one more time here again. Okay. So within the map function, if you want to use the Lambda, you always just write Lambda. Okay. And then the name, the variable name is a temporary, so it doesn't matter. It can be anything. I can say x, okay, and then colon x dot clip or to a geometry or clip to collection, whatever you want to do. So once you define x, you just apply something to the x. So usually be x dot, for example, clip x dot plus x dot minus, whatever you want to apply to the same item. Kind of similar to the number example I show you at the beginning here, right? So lambda, whatever number, it can be x, right? I can put the lambda x and then e dot number x to the power of 2, whatever you want to do. Yes. No, you then you don't use the lambda. You be just the name of the function. So this one, a lambda function in Python is called anonymous function. So because it's just very simple, you can def and then the name, and then you just say return. You have 2 lines. You can just simplify it's 1 line. Yeah. Or you can just ask ChatGPT, give me some Python example, Lambda function. It will give you probably a little bit more. This is a little bit confusing to master at the beginning, but once you understand it, you'll be Lambda, whatever you do, this element, and then you do something to that element. It can be plus, minus, get some information. It can do a lot of things. For example, I can Lambda X, I can get the image date, and then you can return a list of dates. Yeah. So it's not very straightforward, but if you use it, practice, you will get to understand it. Okay, so this we're out of time, so the last 10-13 minutes you can do the quiz. We will continue this when we return next Friday.